Yeah, we are happy to follow your presentation.
Thanks, Sebastian. Hello, everyone. Thank you for the kind introduction. The things I would like to talk about today are mainly based for the direct result of this junior group that Sebastian was introducing, which was mainly about secure analysis federation in intensive care medicine. And I'm not sure whether I will go in that much depth in the sense of technical things. I would rather like to go the full story of challenges in intensive care and why we are using intensive care. I would also like to say something about AI in intensive care as it currently is used or would like to be used. Afterwards, I would go on what's federated learning in contrast and what methods we can use, since I was not really sure whether everyone exactly knows how to go into how this works. Afterwards, I would go on talk about some use cases that we were developing in our past years in this junior group. And then I would talk a bit about heterogeneity of data and also data or domain shift a bit. And then the very practical issues basically that we had, at least in some high level sense. And maybe we can afterwards talk about things and I get some input from you how we can improve on that, since I do not have a really ideal answer on using federated learning yet, and we are basically still trying to get better and learning on that. For now, intensive care, what's the promise and what's the challenge? So some of the major potentials come out of the major issues in the clinic by now. Currently, so here you can see a little chart about how much time was spent on a computer in contrast to how much time is spent in a face-to-face meeting between physicians, but also between physicians and patients. And this was actually calculated while someone was like walking with physicians in an outpatient clinic and actually taking the time on how long they need for every step in their daily work. And the other one is that there are more and more reports and questionnaires that were filled and analyses that say that we have and if you go to the actual wards, then you also see and hear about this. But there are lots of analyses about this topic. There are more and more issues in the ward of having enough patients, people there working there. And for example, one of the most interesting numbers is in this one analysis from Philips Future Health Index from 2024, was that 77% of all leaders that were asked in the clinics report about delays in care due to staff shortages. And additional numbers they say is that 66% report an increased burnout stress and 55% see an increased likelihood of staff leaving. And the shortage will just increase in the next decade. Very likely, or at least it's thought about this. And one of the challenges in intensive care, but also some of the, also again, promises is that the patient heterogeneity in intensive care is very high. There are also lots of reports about it, but one of the easiest numbers that I found was a quick analysis that I did in Mimic4 database, where you can see the numbers or the mean numbers of diagnoses that patients have on intensive care wards versus non-intensive care wards. So they are quite higher than the other ones, which means that patients are more diverse and they have is more complex to learn, which leads to less equal cases that you can use for your training, and basically you need there is a lot of structured data there, but you still have to get more patients and more data from more wards, since the patients are very, very diverse. I actually looked for data volumes, and by here in Augsburg, we usually say that we get about 1 gigabyte of data per day per bed from the monitoring data, like from these devices in the background. Actually, I found also reports about 100 gigabyte byte per day per bed, and I also found something with 60 terabyte per day per bed. I'm pretty sure that this is like much too much for now, but let's stay with that. They have quite some data that is like documented in a very structured way in intensive care, which can be used in a very nice way and which can also be analyzed. For example, there are lots of intensive care databases that were published. Some of you might know, like Mimic was one of the first ones with about 53,000 patients. Then came, I think, EICU or Amsterdam UMCDB, and then we have HiRate from Switzerland and the SIGDB from Austria. And they are the newest one. This is an analysis, or I just looked them up on PubMed in 2024, I think. They had 5 papers on these databases. In Amsterdam UMCDB, they had 27 papers on that. In EICU-CRG, they had over 600 papers, and in Mimic 4 alone, there's also Mimic 3. In Mimic 4 alone, they have like over 900 papers already published only on these data sets. And we are following in with that with our federated learning approaches. And yeah, so one more sentence to data heterogeneity as a main issue. This is again a short analysis of EICU, Mimic 4, Amsterdam UMCDB, and you can see that they have quite a different mortality. They also have quite a different length of stay in the different hospitals. So they stay in Amsterdam UMCDB, they seem to stay much longer than, for example, in EICU, in contrast. And also like the sex is distributed in a different way. And this likely follows in this issue. On the left side, you can see if how it looks like. You see this graph a bit later, since this is one of our use cases. How it looks like if we train data in EICU. Doesn't matter for now what model this is. We get a quite okay AUC. And if we take the same model that we trained here and test it on Mimic, it's sort of random. I mean, there's not really much of an external validation possible here. So the data distribution is very different, and it's not easy to just train on one data set and test it on another, or shift it to another hospital to just use it there. In some cases, it's okay, but it's not always this way. Reasons for these differences are manifold. For example, one of the I'm not sure whether this is one of the most important. Let's say one is SOP differences, like standard operating procedures might be very different. They can lead to different measurement timing, different time on the day when they measure something. Documentation practice might be different. Device measurements can be easy, like in laboratory, they might use other what's called other methods, to say it in a abstract way, or they calibrate it different and so on. Referral to wards might be different. Temporal factors might be different. For example, seasonality. I mean, between the databases that I have in the public databases on the previous slides, they might not change much, but if you take some data from South Africa, they might have different predictability maybe on this if we train on same dates or if the timing is relevant. Catchment area is important. For example, if we train on patients in Munich downtown, like the LMU, patients are quite different in contrast to, for example, Augsburg, which is more rural in contrast to Munich. Then we might have specialty centers like a cancer center, comprehensive heart failure center, or something that might be specific at some places, center size and severity and case mix. I guess I have enough other slides. So there are lots of reasons to have different data in the end. And still, there's lots of interest in doing analysis and doing predictions, any kind of predictions in intensive care, but of course also in lots of other topics. I looked up how often prediction and AI came together with intensive care and PubMed. You can see that there are lots of visuals, lots of publications, especially in the recent years that came up, that are published. And lots of the stuff is about prediction models, like very simple things where you want to predict an sepsis, where you want to predict the readiness for discharge from intensive care, where you want to predict specific cardiac events or hypoxia, or when the patient is in mechanical ventilation, then you want to predict the weaning. So most of this most of these predictions are rather simple, using like standardized clinical routine data, and they are published in very large numbers. For example, in sepsis, I even found a review of sepsis prediction tasks. So there are really lots of them by now. But there's not only like the monitoring data, signal data that you can see here in the background. There, in intensive care, it's also interesting to have lots of other measurement ways, like collecting or measuring movements of the patient, having cameras in order to predict, to see the face or the behavior of the patient, light, sound. Basically, all kinds of things are currently measured and are combined in multimodality or multimodal data or prediction tasks. And here they are again. And in the end, it's interesting, for example, to detect movements or maybe also in facial expression. So there are also manifold. You can predict head position, body positions, and so on, which is especially in the intensive care where patients might just lay around for days without much movement for a long time. And then at one point in time, they just wake up and do something again or so. Or they might fall out of the bed. Or sometimes maybe it's also interesting to predict or to detect delirium via facial expressions and so on. So there are prediction tasks in intensive care is not only based on standard routine sensor data, also on or laboratory data. There are lots of other possibilities. For now, in our group, we are only using the standard data, but I find these very, very interesting. But so far to the publication history in reality, we have lots of risk assessment algorithms, scores in intensive care, for example, to detect severity of a patient case. For example, the Apache 224 is a score that was developed over many years, and basically predicts the risk of mortality and the length of stay in intensive care. Then there are lots of therapeutic or care scores, organ failure scores, specific other scores for classical coma scale, for lots of larger variety. But these scores basically have in common that they are just a very simple calculation of base values or variables. And only in the Apache 2 or in the Apache categories, you can see that there is an increasing number of parameters that is included in the Apache 4 in the end, which was calculated in 2006. And the Apache 4 is by now also a bit more than only like a very simple score. It's based on a logistic equation, and you can have some more complexity in there. And logistic regression is also here the best word, since there's not much AI or machine learning going on in intensive care. One of the few, if not the only, systems that use AI in intensive care is like this Edwards Hemosphere, which uses detection, or which uses logistic regression to detect hemodynamic instability in order to optimize fluids and so on. And which is not so much by now in comparison to the things that are published in like for in the academic sense. And logistic regression is here often used also in comparison like XGBoost or like the classic machine learning systems for explainability reasons that you probably also might know, and therefore there's not so much real actual deep learning or AI going on. But as you can see here in this graph, this is from a paper that I found online where they compared different approaches with different diseases. You can see that the blue ones are like AI, like deep learning systems, and the green. The green ones have are like the classic models, and you can see that depending on the disease, there is sometimes a difference, but sometimes not so much between deep learning and like classical models. And in some cases, even the classic systems are even better than the deep learning models. And one reason, or in one other publication that I found, which explains this in a sense, is maybe here where they compare deep learning and logistic regression in comparison to the number of patients. And here you can see with an increasing size of patients, you also get better results, better performance for the deep learning systems in comparison to logistic regression. And therefore, in intensive care, if the patient number is not that high in the beginning, sometimes logistic regression or XGBoost is even the better solution. And even in the models that we developed until now, mostly the classical variants, especially XGBoost, was the better solution. And patient sizes in intensive care wards are sort of high, but since they are so different, these patients, like from their background and their diseases, the actual number on the specific task, on the specific problem, is not that high anymore. And there we need a joint training. What you can here see is some illustration of a personal health strain, which is one of the ways of doing also machine learning or federated learning, where you transfer the model in a sequential way from one clinic to the next. But for now, maybe I'm not sure whether all of you know the basics of machine learning, and therefore, in very short, in the beginning, you have some data, you have a training data set, you have machine learning algorithm, you have a model, and you have a prediction out of this model. You compare this with the target. You have an error, you're having an iterative error reduction, and in the end, you are having a test data set, compare the data again, and then you have your performance metrics. Only this performance metrics you can actually use for the publication or for the description of your tooling. And here you can see a very common way of how we use this in intensive care. Usually, there are lots of algorithms that use a sliding window approach, where you, for example, have, based on an admission, at first some time frame that you use as an observation window, like these two boxes. to predict some things, some outcome in the prediction window. And in this case, we use, this was a simple hypoxemia prediction algorithm, where we try to predict the next SpO2 value in the next 5 minutes based on the SpO2 values of the last 10 minutes. But here you can see that overall you need a sliding window in order to predict this, since this can happen in any time of the stay in intensive care. Okay, in very short, what is in local training up to a federated learning training? In the local training, you have some own data set of your own hospital information system, which is very specific. In every other hospital, it looks usually different. And in the end, you are training a model based on this with lots of epochs and try and error often, and you're doing this in every single hospital. And afterwards, you can also evaluate this model based on your data in a local setting. In a centralized training, you are somehow merging all this data in one central spot, in one central eCRF database or similar. And then you train your model there, and you evaluate it also on your central model. Usually, often not in the actually local models or the local data sets that are provided. So this is the typical classic study flow that are used for RCT studies or similar. Then you could also use like a transfer learning style of a local training. You could train a local model based on your local data, evaluate it locally. Then you can transfer this model to another hospital. You need some kind of an adapter to this data set, since this data model is based on this data set. Then you can retrain it, fine-tune it, evaluate it again, and you can do this again, which is not the most often used thing for kind of federated learning, but sometimes it's used in order to ship one model from one hospital to another one. For example, I read about these things, for example, in case where a researcher moved from one affiliation or from one institute to another one and tried their own algorithm in a new hospital. But this kind of transfer learning is especially interesting if you, for example, don't have enough data. You could use, for example, train a model on adult patient ICU data here, and then you can ship it to a neonatology department, like a department of like very early born babies, where you retrain this model based on the actual data of the babies, where you usually don't have so much patients, even less, and therefore you could, for example, try to use transfer learning for these kinds of things. Transfer learning is, I guess, especially often used for imaging data where there are lots of models online that you can retrain locally. And with the federated training, usually the largest step, the step that is often overseen, is the data homogenization step, which is like very important. And with this data homogenization, I would also see the task of data quality control, comparison of parameters. Sometimes it's not clear what the source parameters actually are, so you have to do some control over the parameters and what ends up in the actual database that is used for the machine learning. And then you can actually use some local training on your database to create some local models, and then afterwards you can combine these models, like the hyperparameters and or the model parameters specifically, and combine them into one global model via fed average or something. there are different algorithms that you can use there. And then you can use local rounds, then again global rounds, aggregated, put it again to the local hospitals, retrain there, global, local, and so on. And sometimes it's easier or better to do less local rounds and more global rounds, but this is introduce lots of more effort in terms of transferring the model back and forth. And in other ways, it's better to do less local rounds and only some more global rounds. It's often very, very depending on the specific problem you have. Maybe some more things to the basic concepts of federated learning. There are some, if you want to do this, some hospital has, for example, different patients, and some parameters. Another hospital might not have all these parameters, but some more. Another hospital, again, might have these. And the typical way that you might think of federated learning is this one, where we actually use the like minimum data set that every hospital has in common to train on these things, which is called horizontal federated learning. There's another way that I actually did not see yet in reality, which is vertical federated learning, which is when you have the same patients in one hospital as in another, which is, for example, the case when you have a hospital, A or B or whatever, multiple hospitals maybe, and then one insurance, and then you want to combine different patients over different, the same patients with different parameters. So you could start training a model based on these parameters here in the hospital, transfer the model to the insurance, then again improve the model by training on other parameters and so on, which is vertical federated learning. Here I guess this goes a bit too much in depth. This is only like a visual representation of how federated average works. Basically what you have is every hospital has an own harmonized data set. Every hospital has, like in this case, 2 weights for one model and a number of patients on that it was trained on. Like here it's like 100 patients, here it's 300, here's again 100. And in the end, you just have to average these weights over all the hospitals based on the number of patients. And this is basically a very simple method for the aggregation. And as far as I think, this is also one of the things that worked quite okay for us in our projects. You don't have to develop all these things yourself. There are lots of different frameworks available. Some of them are sort of medical specific, like FedBiomed. There's also Flame, which is a bit more biomedical oriented, but in the end, I'm not quite sure what actually is the benefits of all these systems. And by now, we mostly went with Flower, because Flower is a very large, very simple system, federated learning framework that is also has lots of backing from industry and large companies, like also NVIDIA went into this game. I think they went together with NVIDIA Flare. And with that, the system is developed again and extended continuously. And from my thinking, this is sort of the best way of going. But actually, it's also not so much overhead to develop lots of these things, the methods yourself, because in the end, you only have to do this federated averaging, and all the other things is like transferring the information. One of the most important hurdles here, I mean, I introduced this topic before with the different data, what did I say? Data heterogeneity is the usage of what is it called? Independent and identically distributed data. So in a classical sense, in classical statistics, you would ideally want to have independent data. That is where parameters are independent of each other, and especially between the different cohorts. And you want to have a similar distribution of them, like here. So overall, they are very similar, and they are like for every parameter, and they almost have the same size and so on. And the problem with different routine databases is that it's non-independent and non-identically distributed. So in reality, you often have very, very different data. So you might have a location shift of the mean. Means might be very different in the different hospitals. Variance might be very different, like in wider spread or smaller. Over shape, like the data might be like a nice Gaussian distribution, or it might be a left skew or right skew. Quantity might be different. And somehow in federal learning, you have to work with these things. And in a real world scenario, which is, I guess, in my point of view, also one of the main issues with why this is not so much used yet in reality, is that you would have to work with all these things without really having access to the different databases. Because what we are doing, or what many people did, was using these public databases and also own databases to train federal learning models. But you always have full access to the, at least you as a person or as a developer, have full access to the databases. The algorithm might not have access, but you can tweak it locally in a specific way in order to overcome these issues. If you are working on a central spot and want to train models in a good way, that they are working well in an external validation in different hospitals, you would not have so much access to these data sets. You might not be reliable for the data extraction, for this whole data extraction process, and you also do not have so much control over the data itself. So in the end, this is a complex topic in order to work on that, but it's even more complex if you want to work as a researcher on a central spot with different centers that work with you in a federated project that you somehow have to manage and somehow have to overcome. And this is basically only the input data or the features that might be relevant. But in contrast, which is even, I'm not sure whether more complex, but which is another hurdle, is that the outcome distribution might vary strongly. For example, with the blood transfusion use case that we have, we use this for public databases and our own hospital database. And you can see that in many of these, you have like 20 to 25% of positive blood transfusion cases in contrast to non-blood transfusion use cases in the database. In Augsburg, it's exceptionally low with only 1%, and EISU also only has 5% of positive blood transfusion use cases, which you somehow have to also include in your models, which is not specifically trivial. And all these heterogeneity issues lead to a drift in the models. For example, in the beginning, you have global models, but then the local models might, with every round, drift into different directions. And then if you calculate your federated average, this might end here, but the global optimum might be here. So you might need to use different ways of optimizing the overall outcome by maybe not using federated average, maybe by federated procs, fed-procs, or other ways, or you're using client-side optimization tools like Optuna that we also already used in federated learning setting, which works also quite good. But it's not as trivial as I have a model and I'm just running it at different hospitals. And in the end, it's also a question of how you train and validate the actual models. So if your approach is local, then you train your data on a local data set. You can validate it on your own site, on your own local data set, but you can also use validate it on other sites, which might then be an external validation. In the central approach, so a central machine learning approach, you would pool all your data to one place. You can then also validate it on this pool data, where you like randomized training and test data sets. But you could also train, or not train, but you could also validate the final model on all the sites that you used for the pooling. And in the federated setting, it's even more complex. You train the model federated. So in the end, you have a federated global model that you can then use to validate it locally at every site. You can use the federated model before averaging on a global scale without local boosting, which you can use on validate on your own site, but also the others and so on. And you can do it with boosting, and you could also make it in a way that you train your data on via leave one out. You train your federated model, also global model, on, for example, if you have a federated learning setting with 3 participants, you train it only on 2 participants and you test it on the other one. So you have a nice external validation. And I guess I never really looked at, or I never completely checked, and I'm not sure, not really convinced of it, but I'm pretty sure that it is this way, that lots of models, even if they are using federated learning, or if when they are pooling the data in a global sense, they are often training on the pool data, but they are also validated on the pool data, which often has only like the patterns of one of the largest sub centers or sites, which might not work as well if you would train or validate this model afterwards on all sites differently. Okay, so would like to come to the data as the foundation for FL, since in my thinking, this is one of the most important things, where you have to smooth out all this complexity in the beginning to get some nice data to go on. And as you, just as a reminder, there are lots of databases which are already used for these things. And they all come with an proprietary data format, usually as they extracted from their hospital information system, as in reality. And we are currently using OMOP, Common Data Model, for harmonizing these things, these data sets. And if you don't know it as much, basically it's a set of tables with a person table, with a visit occurrence table, like this is the patient case, with a visit detail table, which is the movement or the time of the patient case where you are, for example, on intensive care, or where you're on a cardiac ward or similar. And then you have lots of tables for measurement, observation, and so on. Like it's similar to an usual data warehouse like I2B2, but divided by a specific topic. And then you have lots of other like more meta tables that can be used besides that. Since there's not really nice standard tooling for that, we developed one ourselves, where we have like a structured way of defining mappings, like tables to tables, field to fields in these tables, dictionaries, like the semantic mapping, and also resources where we can provide filters or custom transformation methods in Python directly, which requires not much installation effort, runs without installing servers and so on, which can be also shipped with federated learning pipelines. And we use these things, which we will probably also publish in the next months. We use these things to like transfer all these databases to OMOP Common Data Model, which was already done before, but sometimes it's with error, sometimes the infrastructure is a bit different, and so on. So we are providing a new way here. But still, this is a somewhat complex way task in order to use this specific ETL task in a federated learning setting with many different participants. Since every single hospital has to do their own ETL, maybe someone from the central initiating side could go there and help out and so on, but it's still in the environment of the specific hospital, and so there's a lot of overhead that is on that topic. And if you have a project funded somewhere, you might have enough money for your people, but you often might not think about that the others also have to do all these tasks and do the ETL, also have to install tooling for federated learning and so on, and also supervise and update and so on. So now to the actually to our actual modeling. Maybe I should go a bit quicker over them. Basically, we have one model where we try to predict the weaning from a mechanical ventilation in intensive care when the patient is like mechanically ventilated. We had lots of different methods of training and validating them. Basically, we used EICU and MIMIC, and partially we combined these like in a central way. Partially we tried local training and external validation, and basically this was the best we've got with our approach. Like it's an okay measure or an okay AUC with for EICU, and with MIMIC the best we've got in the end was like an AUC of 65, which is not really nice. The other use case, so this was like a single center study with local training without federated learning. This was only like to getting into the modeling. Then we had another approach where we try to predict the need for a blood transfusion. Here the gray bar is the increasing amount of data we use in an observation window, like the first hour after ICU admission plus the previous 6 hours, 2, 3, or 6 hours into the ICU stay to predict the rest of the first day and the rest of the second and third day. And then we tried also only using pre-ICU and only ICU data prediction. And in the end, we saw that there's a bit of an increase if we use until 3 hours, and then with 6 hours, it gets worse again. And if you use only pre-ICU, it's bad. And if you also only use the first hour, it's also quite okay and not really much worse than like using 3 hours. Okay, same models in FL now. Here you can see a more complex way we used of predicting the weaning use case. We used EICU CRG, MIMIC for our UKA data, HIRIT, and Amsterdam UMCDB. This is the local training, where you can see that the AUROC is quite okay, which is also the best. If you do a local training, it's always the best in comparison to the central and the federated. Since you train locally and validate locally. Here you can see the centralized data training and centralized validation. Here you can see the macro average of the federated training and validation. And you can see that it's quite almost the same. Centralized is a bit better than federated if you do the macro averaging. but the local is mostly the best. Afterwards, we tested it quite a bit different. We compared like the federated local model after boosting with the actually local model, where you can see that the federated is always a bit worse, comparable, but a bit worse. But it's almost equal in the end. So federal learning is sort of the same as local learning, which we wanted to really like to have in the end as an explanation or as an outcome. And then we looked at the federated learning results versus decentralized model. And then we saw if we actually use the centralized model that was trained centrally, but actually validated on the local dataset, it was a bit worse than the federated model, which is quite a thing that we really wanted to or liked as an outcome for this federated learning use case and training. And so we were really happy about this results, that it was even partially better than the centralized model. But then we came to the second use case with the blood transfusion, and attention, the order changed here. So FL is here the right one. You can see that federal learning is always worse than the centralized model. And then we came to a point that it's really depending on the use case where you want to train a model or where you use a model and validate a model. It's not as easy as you can say federal learning is better or centralized learning is better. And here you can see that federal learning is a bit worse, but with hybrid it's really a lot worse than the centralized model. But with UKA data, our federated is even better. But mostly it was not so good. And then we did this whole system or this whole evaluation with leave one out. So we tested these models here on EICU data, and EICU was not used for the centralized learning, not used for the federated learning, and not used for a local model here. And here you can see that the local models vary widely. So this is a model that was only trained on hybrid and now evaluated or tested on EICU. This was trained on Mimic and evaluated on EICU, which is the best here in this setup. And here UKA data is really working not good with EICU. But what you can also see here is that centralized learning is always staying on the top. So centralized learning versus federal learning is overall, if you want to do an external validation, the better way of going than only using a local trained model. So this is, I guess, the most interesting outcome out of all these bar charts. Yeah, and sometimes a local model is even the best. No, the federal learning model, sorry, tested on our UKA data. Okay, now a bit more to heterogeneity. The next way after we had all this evaluation, can I stop this for now? No, I cannot. You can see the what is it, Jensen-Shannon divergence, which is increasing. And if it's 1, the distributions between both data sets are very different. And if it's 0, it's almost the same. So in the next step, we try to find out more about after we had this previous diverse results with the federal learning, we tried out more to get more information about the data itself. So we tried distance metrics between databases, for example. And this is one comparison. We can see that if the Jensen-Shannon divergence is smaller than 0.2, then it's low heterogeneity and so on. And here's another analysis where we used Kullback-Leibler divergence, which is a bit different, but overall similar. And this is again the blood transfusion use case. And you can see if you use all patient data or calculate the Kullback-Leibler divergence over all parameters of all 5 databases, then you can see that HiRET is the most diverse or most different compared to all the other databases. And if we use the data from no blood transfusion, it's a bit higher. And if you use the blood transfusion use case, the difference goes up tremendously in comparison to the all patient setting, which basically means that the blood transfusion use case seems to be handled very different at the different hospitals, which might be a reason that, or an explanation why federated learning might not work as well here if the databases for this use case are very different from the others. Yeah. But overall, you can also see that some databases might be more equal here. For example, maybe Mimic and UKA data or UMCDB. And so this is also another concept that is sometimes used, that you group databases into different groups where you're doing federated learning, and you're only doing the federated learning in these groups to provide a more generalizability or more generalizable model in comparison to other models. So you could even use some heterogeneity analysis in the beginning in order to find out which hospitals can be combined in the model, in order to see what model works best for your hospital. Another thing that we tried is that with propensity score matching, with randomized clinical trials, or randomized clinical trials rely on randomization in order to compare the outcome or the overall similarity of the groups of the treatment group. In an RCT, you have a treatment group and a control group. But in routine data, this is not as easily doable if you have specific other hospitals. And we tried to do propensity score matching in a federated learning setting, where we at first selected a patient group or selected scores in our hospital, shared this with the other hospitals in a local lab setting of federated learning, and then identified the fitting control group. And then we used this propensity score match group to do federated learning. And basically, you would use standardized mean differences. Sorry. To calculate the difference after propensity score matching. And you can see in baseline unmatched patients, the difference is quite high. And if we are doing propensity score matching, we did 2 strategies. I'm not going into detail here. If we do propensity score matching, the threshold is below 0.1, which means that it's it's quite okay, but the balance is quite okay. Afterwards, we developed a prediction over these groups, and basically you can see that it's not really different. The no propensity score match groups is quite similar to the cross-hospital propensity score match groups, and basically it's the same, and it does not really improve much here, and therefore we also stopped a bit working with propensity score matching for now. And now I have the last 5 or 6 slides of this presentation. A bit more about governance and privacy. I mean, it's a complex topic. Using federated learning in this sense, we have one project, for example, which actually does not use federated learning, but secure multi-party computation, but it's quite similar. Every state in Germany has other laws. So in the end, you have to pay attention to every law in every hospital, which probably also know most of you. By now, it's much easier if we only, or maybe to the laws, you have lots of other laws than only the state laws. You also have EHDS, AI Act, and so on, which is complex enough. And especially with this other project that I just mentioned, we have 4 hospitals working on a federated analysis using secure multi-party computation. And I try to coordinate, or I'm coordinating this, and every single hospital has other issues. The one hospital wants an, I'm not sure in English, Datenschutzfolgeabschätzung. The others are not really caring about that. The others do want to have more security on the algorithm. Hence, it would not be necessary since the algorithm itself is like complex. It's a very complex topic since every participant has other requirements and needs to be included somehow in the discussion. Single ethics committee applications are improving this a lot. But there are lots of other discussions, especially if you want to ship your own code, your own environment, for example, as we do as Docker containers. Every hospital has their own data protection officer, has their own information security officer, has then afterwards, again, the IT that actually has to run it and approve running it and so on. And they all have to be convinced that it's good. And it's not as easy as one thinks in the beginning. Especially if you want to actually use your own data from the hospital. You also need local admins that like manage the systems. You also need local data extractors and ETL people that are doing all these tasks. You would need funding for all these things, which is really not that easy. And this is actually the most complex topic of this whole federated learning setting in real world scenarios. And I guess this is also one of these reasons why federated learning is actually not used that much by now, but mostly in laboratory settings. Yeah. Then the next question is, federated might not be anonymous. We in our, since there are lots of projects that focus on data privacy of all these topics of federal learning algorithms by using blockchain, by using this and that, we were mostly focusing on how the data is actually working, and we are less focusing on this data protection things by now. Also in reality, with the actual projects that we're doing with other hospitals, we are more focusing on we are trusting each other and trying to get ahead with the actually data analysis and the modeling, and less with the federated and data protection issues. Because if you use more data protection, then the data becomes a bit more complex and less specific and so on. And you are introducing lots of more complexity in there. In order to come to this other project that we are using in reality with these 4 hospitals that I mentioned before, do we actually need to trust each other? And this is basically, if, for example, we have 3 persons and every person wants to have the average overall of all persons, which might be 200 here. What do we really have to share to an central place or to the other hospitals in order to calculate these values? Sometimes you might not need this really most comprehensive system that actually does everything. Sometimes you can maybe also do with very small things and lots of improvement in the whole system. And this is also something that we are working on, for example, to comparing the PONF rate between different hospitals. So we can calculate a secure median, for example, with secure multi-party computation. And in the analysis, we would only see our own PONF rate over the last months, and then we see the median that is calculated via a secure way so that actually no one has to share their own data to the outside world, because some of the data gives lots of information out to the public that might reveal more about the actual practice of how patients work or how bad and good the hospital is than you actually want to share. And with that, I'm coming to my last slide and maybe some discussion. Intensive care is a very interesting topic, data-rich, but sort of case poor and very diverse. Generalizable models need more sites and would benefit by a lot by federated learning. With federated learning, there are many different approaches. I did not tell all of them yet. In order to let the models travel between the hospitals instead of the data. You might still, or you still have potential issues with these models in the end. But in order to scientifically go ahead with the actual clinical topic, this might be okay. In contrast to developing better security protocols for the future. And the hard part in these projects actually are the data heterogeneity, technical supports at every site, and coordination, but not always the algorithm itself. And I would also, since I really think that lots of people report their model performance afterwards on the data of the global models, I would actually really like to see more on the actual local models in the validation afterwards. And with that, I would say I'm finished. Are there any questions?
Yes, thanks a lot for the excellent overview of the potential and current approaches of federal learning. I think, Mathias, you presented indicators that federated learning depends on the use case. Maybe we could discuss further the effect the specific data encoding would has for the success versus central approaches and local approaches. Let me ask the auditorium, are there some questions from you? So you can just unmute and ask your question. Andreas, for example.
Yeah, I wasn't sure if there's a raised hand. Sorry for that. Hi, first of all, Entschuldigung, Deutsch reden. Ich bin ein bisschen im internationalen Bereich. Erstmal vielen Dank für die schöne Präsentation, sehr guter Überblick. Zwei Sachen, die mir aufgefallen sind. Das eine war beim Thema Datenprotection. Ich glaube, das ist nicht so das Problem, wenn wir über OMOP-Daten reden, weil sie erstmal sofort de-identifiziert sind und auch aggregiert dann weitergegeben werden. Also ich glaube, der Datenschutz normalerweise hat da nicht so viele Probleme. Zumindest ist das unsere Erfahrung. Und B, meine zweite Frage oder eher eine Anmerkung. Seid ihr irgendwie involviert in die Odyssey-Community, Odyssey-Knoten Luxemburg, also Luxemburg wahrscheinlich nicht, aber Deutschland, weil da könnte man sich auch sehr viel Hilfe holen, die jetzt nicht auch direkt halt auch Budget sensitiv ist.
Hallo, danke für die Frage. Also zu der ersten Frage mit dem Datenschutz haben wir tatsächlich am Ende auch die wenigsten Probleme. Die meisten Probleme kommen dann, wenn tatsächlich jemand das installieren muss und dann Vertrauen auf die Systeme haben muss, dass die keinen Quatsch machen im eigenen System oder keine Ports oder ähnliches öffnen. Und
korrekt, aber da gibt es ja auch schon Hilfestellungen aus der Community. Das ist ja jetzt nicht das erste Mal, dass sowas installiert wird.
Ja, meistens, also die Leute, mit denen wir bisher zusammengearbeitet haben, die haben alle das gleiche Problem und für die ist das alles irgendwie neu. Es kommt immer darauf an, mit wem man, wenn man zum Beispiel über das Forschungsdatenportal geht, die arbeiten ja auch gerade dann an föderierten Analysen und wie die vorangehen. Und da wird es da sicherlich einen klaren Ansatz geben, wie man da vorangeht. Und da werden auch die ganzen Verfahren, soweit ich das sehe, sind einigermaßen strukturierter. Da hat man aber meistens auch das Problem, dass man halt nicht immer alle Daten hat, vor allem nur das, was wirklich im Kerndatensatz drin ist. Und oft sind wir unterwegs mit Daten, die halt sehr viel spezieller sind und wo wir halt zusätzliche Daten brauchen. Und deswegen haben wir bisher erstmal unsere eigenen Pipelines aufgebaut.
Macht komplett Sinn. Sorry, ich will nicht jetzt hier alles überschatten. Ich weiß nicht, es gibt 2 Projekte, zumindest vielleicht im Nachgang auch nochmal austauschen, die mit ICU-Daten arbeiten, auch noch zum Teil. Und ich weiß aus eigener Erfahrung, dass die Med-Uni Wien auch geomopte Daten hat. Also von der Seite, falls da mal Interesse ist, kann ich gerne auch einen Link legen.
Mit den Wienern arbeiten wir sogar schon zusammen mit einigen.
Achso, Oliver Kimberger
Aber
ist
noch
mein
nicht mit
Kontakt.
OMOP. Noch nicht mit OMOP tatsächlich. Vielleicht
Okay.
haben wir die falschen Kontakte momentan.
Das weiß ich nicht, das ist der Oliver Kimberger. Und,
Ja, genau, mit
der
denen
prüft schon.
kenne ich auch.
Aber der hat-
Aber ich wusste tatsächlich noch nicht,
Genau.
dass die OMOP-Daten haben.
Aber wir haben es damals für Sie gemacht. Deswegen
Okay,
weiß
gute Information.
ich's.
Zur zweiten Frage mit OMOP-Community. Ja, also nein, wir arbeiten nicht wirklich mit denen zusammen. Aber ja, wir hatten schon Kontakt aufgebaut, aber das ist am Ende darin geendet, dass ich tatsächlich nicht richtig weiß, was es mir momentan bringt, da zusammenzuarbeiten, weil ich eine
Okay.
größere Menge an Meetings mit allen möglichen Sachen habe und ich habe gerade, ab irgendeinem Punkt muss ich mal überlegen, an welchen Communities nimmt man teil und welche nicht. Und ich meine, OMOP hat einiges an Tools, die selbst mitbringen zur Transformation, die ich persönlich nicht so besonders gut finde. Aber gerade, es gibt auch andere Settings wie RICU, die diese verschiedenen öffentlichen Datenbanken zusammenziehen. Es gibt Blended ICU, die zusammenziehen. Aber so richtig mit OMOP zusammen gibt es das momentan nicht. Und wir haben es halt einfach out of the need damit entwickelt.
Ja.
Aber
Ist auch wirklich schön gemacht. Wie gesagt, sorry, eine letzte Sache und dann halte ich wirklich den Mund. Es gab in Rotterdam jetzt vor 2 Monaten, glaube ich, eine Konferenz. Es gibt jetzt auch eine Kombination NV-Flare und den Odyssey-Tools. Also falls das von Interesse ist, kann ich da gerne auch nochmal kommentieren. Also wir haben OMOP-Tools in NV-Flare eingebaut, damit man eben nur eine Sache installieren muss und auch die Interaktion mit den Sites halt verbessern kann.
das heißt, Sie arbeiten in der Odyssey-Community mit.
Genau.
Mit den Dresdnern oder Niederlande?
Ines kenne ich sehr gut, ist Dresden, glaube ich, Ines Reinecke.
Ja.
Wir sitzen in Luxemburg, aber wir arbeiten europaweit und sind halt seit 19 in der Community sehr aktiv mit vielen Projekten.
Okay. Ja, klingt gut. Ich weiß auch, dass OMOP oder Odyssey eine Zeit lang ein intensivmedizinisches Add-on entwickelt hat, aber das ist irgendwann auch wieder eingestellt worden. Wir hatten eine Zeit lang auch überlegt, ob man in die Richtung weitergehen kann und das nochmal neu auflegen kann, aber naja, irgendwann mal wieder.
Es gibt 2 Projekte, die mit ICU-Daten oder ein Projekt, was mit ICU-Daten und OMOP arbeitet, das ist der Koordinator am Erasmus. Mir fällt der Name noch leider nicht ein. Ich suche ihn raus und schicke ihn dann per E-Mail oder per LinkedIn.
Sehr gern.
Also auch total gerne, wenn es Links gibt, die vielleicht nicht nur für Mathias Kaspar hilfreich sind. English. So in case there are links which are not only relevant for Matthias, but maybe other visitors as well, just share them with us and we will place them directly below the talk. Thanks a lot. Other questions? Or comments? So where are your challenges? Would you agree on the relevance or the approach? Is the central approach always better than...
Or maybe you want to take part of one of the analyzers and do the tasks of local transformations and be part of publications?
Perhaps I can just raise one question. So I'm completely amazed about all the methods you've tried so far, but in my point of view right now, I guess the biggest challenge is to come to the translation right now from the laboratory part to the routine care. So what do you think are the biggest challenges, and what kind of are the next steps for you to take in part of becoming a part of the routine care in the end?
There are so many people working on these things, and I'm not sure whether someone will succeed. I'm actually not sure. There's so many issues. I mean, every single hospital information system developer has their own data system. Something like OpenEHR in every hospital as a databases would be nice, which we will probably not get in the near future. More open hospital information systems that would also be allowed to integrate these systems into their hospital information systems would be very, very important. I mean, if you have a second system that provides some prediction or something, nobody will use it because daily routine care is so full of work that no one will open another system in order to do something. Actually, we have lots of other problems here. Sometimes Orbis requires 10 minutes to start up before one can do anything on their computer, on their hospital information system. So sometimes it looks like all these AI things are so far away from routine care that I'm not sure whether it makes sense or whether we should just use this performance to install them some better software systems. But in reality, I mean, to be more honest or less on the funny side, I guess we need more startups that actually develop these things and go for a medical device product. But with these things, we have some effort. We have here, for example, from Bavarian State, a larger project for what is an innovation hub built up. There are lots of these hubs. In Munich is a large one, probably everywhere in Germany or other states, where ideas from the clinic and also research projects are supported in extending them, making them more productive and providing systems for routine care. But I'm not sure whether they will end up good or will be usable if the systems are not directly integrated into a hospital information system in the routine path of or workflow of the people. So
Thanks
I guess
and maybe a follow-up question in that regard. So like you pointed out that you have to adjust a lot of the data to get a centralized, semantically comparable data set for the different locations participating. But then I would assume like it's not only the semantic annotation which must be standardized, but as well the standard operating procedures, maybe laboratory testing should be normalized among the different participants. So my question would be, what is the standard pipeline you would suggest to prepare for the training, which at the end might be the easiest part of the whole pipeline? Maybe the question as well could lead to a discussion with Andreas.
Good question. Honestly, I'm not sure whether I can provide a good answer to this for now. So we are currently doing this syntactic and semantic mapping of the base databases to OMOP, Common Data Model, and then we afterwards do some statistical comparisons between the hospitals' data sets. Also within hospitals, like sometimes one hospital has multiple parameters that can be used for the analysis, which are coming from slightly different laboratory methods also. Basically, for now, we are only comparing them and seeing whether they overall fit, or if they are not fitting, we are taking them out. And for now, we didn't really change them before really actually doing the training. We might do some fill-ups of missing data also, but for now, not so much more. But we are working actually on projects on having some more robust systems against all this heterogeneity in the databases in order to better analyze it and in order to overcome these issues. But for now, we don't have so much yet. So we are working on it. One of the larger open projects.
Yeah, because my name was mentioned. I can agree. This is a completely global problem so harmonization is a global problem rather. And the community, the Odyssey community, is working on this. There is a lot going on in the oncology field, in the cancer field. Not so much on the ICU, because there are not so much ICU data in the community, to my knowledge. But typically, yeah, one is comparing the data dictionary, source books, whatever you want to call it, in order to make sure that there is at that level an harmonization already possible. And but it's a long way to go. That's an active field, the full Odyssey community. So the guys behind OMOP are working on. And again, I put it, I think, in the chat. I can only recommend to have a look once in a while, but I agree as well, there's so much you have to really select what you're doing, where you are getting involved in. But you're not alone. That's the only thing as well to keep in mind.
By the way, thanks for the comments in the chat. I already copied it for later.
And there are further questions as well in the chat.
Maybe one addition to this. I mean, we even have an issue in our hospital. At some point in time, we thought we found all the laboratory values that are important, and we used them, and we saw some diversity in the data, but did not really pay too much care at this time. And at some point in time, we found out that there's another label or another flag that we forget, which says whether it's like, what is it? Arterial or venous blood, which is quite important. And yeah, and so this is even on one hospital. It's like an endless work of getting this data correct in the end. Thanks.
So, and then looking to the chat, there are further questions. Tim asked some questions. The first one maybe we've answered, which support from which community is available. So I think Andreas will send us some links, maybe Matthias as well, and we will place it below the video on the XtraTracks page. And experience from Hanover is that hospital IT and Betriebskonzepte, so organizational stuff is a bigger hurdle to parse for researchers. And about the science, he highly doubts that exchanging medians solves data leakage problems. Maybe someone want to comment on that. Maybe you also want to try Feature Cloud. And yeah,
we actually looked at Feature Cloud at some point in time, but we somehow decided to not use it. But I do not really know anymore why, actually.
And I think exchanging medians, you had as well. Was it the federal non-fed-up?
I'm not sure at what time I said this for the propensity score matching or so. Probably not.
Yeah.
No, probably for this secure multi-party computation thing, and there this will not have any issue. I mean, there's no data protection issue.
Yeah. Yeah. So thanks, Tim, for your comments. I'm not quite sure. Are there further questions? Otherwise, we could call it a day.
Okay.
Excellent. Then thank you very much, Matthias. I think it was really an enlightening talk. which showed us that it really depends on the data to be considered, maybe on the partners. There are a lot of challenges left, I understand, and it's worthwhile field to further investigate, right?
Yes, it is indeed.
Thanks a lot. Yeah.
Thanks for
Thanks a
the
lot for
invitation.
the presentation.
Thanks for listening.
Thank you.
Bye-bye.
Have a nice evening.
Goodbye.
As well.
Bye-bye.
Bye.